Without a roof, the wind was sweeping into the stadium bowl and rolling onto the track and field area, creating turbulent vortices.
Track is a little bit shallow.
A partial roof, stretching almost 30 meters over the bowl, forced the wind to flow over the stadium.
They were pretty conclusive. It showed quite clearly that the roof was extremely valuable in controlling and attenuating wind movements down onto the track and field level.
The team quickly got to work on designing a partial roof structure. But with just 6 weeks to the stadium press launch, the engineers began to reconsider their strategy.
There's people working 10 hours a day designing it, and we were confident we were going to launch the press. We had everything set up, and that's when the design team said, you know what, we could do this a little bit differently.
The heavy-duty roof was designed to take the immense structural loads created by wind. But the design was getting too big and using too much steel.
It was then we started looking at the weight of that structure and how you could do it a bit differently, and the idea just clicked that we could do a really sophisticated, lightweight cable net roof right at the last minute.
The cable net design was a masterstroke. Assembled like a bicycle wheel, a lightweight steel frame would support a thin fabric roof. When tensioned, the roof would take the immense loads whilst using a fraction of the original steel required.
Nobody's going to put back the opening date of the Olympics. Every time you come up with a solution that doesn't quite make it, you get just that little bit panicky. And we started to realize that we've got a solution right, we've cracked it.
Now all the team had to do was race to prepare for the design's launch to the British and international press.
It was all hands on deck to get the design right, because we knew what we went out on with then was going to be a picture for the first time in the world's eyes of what London 2012 was going to be.
In November 2007, the day of reckoning finally arrived, and the stadium was revealed to the world.
But this is a purpose-built athletics Olympic stadium.
And the design delivered in spades. In May 2008, Team Stadium kick-started construction. Construction across the Olympic Park depended on concrete. But the ingredients for its production didn't arrive by gas-guzzling lorries. London 2012 had another strategy, which harked back to Britain's great industrial age. The Olympic Park had its own train hub, and London 2012 set a seemingly impossible target: to transport by sustainable means up to 50% of the construction materials to site. Attempting to meet this ambition was a full-time operation for logistics manager Peter Cummings.
We do 8 train loads a day, approximately 1,500 tonnes per train, so that's about 12,000 tonnes of material coming in each day, Monday to Saturday.
Once the materials were unloaded, trucks only had to make a short journey to the on-site concrete factory. Keeping up with demand was a relentless task.
I love pressure. I get a buzz out of doing it. It's not just a matter of just turning up to the office day and going through the usual things that happen. Let's have a challenge. The challenge is the Olympics.
Each train delivered the equivalent volume of material as 75 lorries, which didn't just eliminate traffic chaos, but created a staggering 5 times less CO2 than road transport. The train hub was so effective, entire bridges, as well as other building supplies, were all delivered by rail. Peter's role is one of thousands on the Olympic Park, but he reflects a pride common across the project.
Well, it's being part of something, isn't it? And I think, oh, I handled them tiles, or oh, I handled that bridge, or I was part of that concrete section that built that stadium. So yeah, that's my legacy.
Construction companies had a free choice over transport. And trying to convince them to switch from road to rail wasn't an easy ride. But shifting materials this way was so fast and cost-effective, trains alone beat transport targets, with 57% of supplies rolling in by rail. By November 2008, it wasn't just trains that were on the move. The tunnelling phase to shift the power lines underground had been completed. The pylons could finally be demolished. The Olympic Park site was instantly transformed, and for David Higgins, also set a benchmark.
The tunnelling project was hugely ambitious from the start, and it was the blueprint for the rest of the project. As I used to say, the other projects as they started, well, if the power lines team can do what they did in that environment and set this new level of standard, you can do it too.
A phenomenal workforce, nearly 10,000 at their peak, had to meet David's high expectations. 20% were recruited within the surrounding districts. But high unemployment and a huge skills gap remained a problem. So on the Olympic Park's apprentice scheme, more than 240 people developed their construction skills alongside expert tutors. Apprentices then put their training into action on projects across the park, like Francis Hafner.
The training has changed my life around because, like, before I wasn't doing anything, I didn't have any skills. As a qualified person, I have a better chance of getting a job, so I'm really happy about my future now. Coming from Sierra Leone, I came here year 2000, and it was really hard to sort of catch up. I just came from a war basically, so I was a bit traumatized. I didn't know anything, I didn't know who my parents were, and I didn't know what to expect. When I came, I just struggled to basically get my head together. All I want to do is just keep going until I become successful and maybe be an inspiration to other young people that you can come from nothing and become something.
Whilst Francis was mastering how to lay drainage pipes, engineers were on their own learning curve to build the Olympic Park's most daring venue. A structure that pushed everyone involved into unknown territory.